Hello everyone, welcome to the I Get It webinar session. Today I'll be talking about industrial design, workflows, and techniques. I am Eric Banson, I work for I Get It, and I am a subject matter expert here with industrial design. So let's go ahead and talk about what we'll see in today's webinar. In this session, we'll talk about the industrial designer's deliverables. We'll learn techniques and workflows which the industrial designer uses to communicate with engineering and manufacturing. And we'll learn how current creative and CAD software are integrated within the design processes that the industrial designer uses. Now, before we begin the actual webinar, I'd like to take you quickly through our myigetit.com website. It's a fairly new website that we have, and I'd like to show you that we have at the top, when you come here, you can browse our catalog, view subscriptions with these buttons here. If you come across the top, we have the catalog up here, subscriptions, we have I Get It for Enterprise, we have blogs with business blogs and tech blogs, we have programs for campus, author, and resellers, and we even have a little bit of interest about us as well. So if you just come here without having a sign-in or anything, you can go to the catalog, and you can see here within our library we have Autodesk, SolidWorks, CATIA, 3D Experience, NX, Team Center. We have a lot of offerings for online training, even GD&T and Creo. Now, if you select on any of one of these, say like NX, you'll come to the course catalog, and in here you'll see the most recent list of our courses. And you can look at them by selecting the View More button. And then in here you can see that you'll get a description about the course, prerequisites, the target audience, and also take a look at the curriculum of that course. You can even select on it, and you can see what type of topics are in which of each of these curriculum units and lessons. Now, if you do have a sign-in, go ahead and select Sign In. You'll come to the Sign In page, and I'm going to go ahead and I'm going to sign in, and you'll come to this main page. And here on the left, you'll see you'll have a dashboard. You have your learning, where here you can go ahead and select the categories of the courses that you wish to learn about. You also have then that particular version or that year version of of that particular software. We also have assessments. We have learning paths, history, and then we go back to our catalog, which then takes us back, as I showed you earlier. This is all within there. We have quick starts, we have tech tips as well that you can select on and go through and read and actually go through procedures with those. And of course, if we head back up to our dashboard, you can also see your popular roles, your continuous learning, and a learning path. And you can see the time spent as well. So with that, let's go ahead and begin the webinar with the industrial design workflow and techniques. So first of all, let's talk about what an industrial designer is. And basically, industrial designer is a most noted for their creative ideas, sketches, styling, and prototype models in their respected industry. Their deliverables contain everything from research data to working prototypes, from sketches to CAD models, helping developing processes to reverse engineering. These deliverables all depend on a company's needs or situation as how an industrial designer is placed and where he's placed in what area within a project. So to discuss some of the on-the-job deliverables of the industrial designer, they're listed right here, is to define the problem or challenge, research the product, consult with manufacturing, engineering, and finance with findings, Brainstorm and conceptualize, meaning sketches, renderings, CAD models. Prototype, test ergonomics, sizing, proving out concepts. CAD, examine engineering and manufacturability process and the feasibility. Refining and evaluating design with testing. And then finally, the final presentation for approval. So let's take a look at the product life cycle process. And with what we just talked about regarding the on-the-job deliverables, we can see here where does the industrial designer fit within the typical design and manufacturing process. So we go usually from left to right in this image here. And this at any point can also loop back, as we'll see in a little bit. So first we have the requirements of management, we have the portfolio management, and then we have conceptual design, product engineering, manufacturing engineering, simulation and validation, build and produce, test quality, sales, distribution, maintenance, repair, dispose, and recycling. And we see how right at the beginning, industrial design always kind of fits within the concept design area, at the very beginning or close to the very beginning of the product life cycle. But as time has moved on, more hats have been given to the industrial designer. And you can see now where they actually fit in. They fit in a lot more in these different areas than you'd expect. And with that, the reason why they fit in is because we have design thinking. And basically this design thinking process is basically using the design thinking process or methodology empowers people to be innovative and collaborative in solving problems. Ultimately, the goal of this process helps to anticipate obstacles, which then allows the product to cycle or recycle through the process, eliminating as many issues possible that might occur in manufacturing, final production, and consumer use. Meaning that the industrial designer is going to start at the research level. He's going to work to the define level. Then we're going to go into ideation, where we come up with a lot of the sketches that you've seen in some of the other slides, and then we'll move to more of the engineering process with CAD and prototyping, and then do it all over again if need be. When we get to that prototype section, we'll have to maybe research something that we find out that didn't work. We'll have to redefine the whole project. At that point, we could do more ideation, come back around to fix what we found that didn't work within the CAD and prototype, and then move on through the product life cycle. This is the whole design thinking process. And we'll kind of go through this with an example that I actually went through personally years back. Now let's move back into our product life cycle process. And we can see here what we just talked about, that design thinking and that process where we kind of went through all the different types of a circular motion. And you can see here how we started at requirement management, go all the way through up until simulation and validation. Before we go to build and produce, if we find any issues between any of these areas, the industrial designer works within this. He can help solve a problem, or we can actually redefine, go back, do research, and then go through the process again. And that's what this here illustrates, how far he can stretch from one point to the other, and then help move the process into either redefining or helping it get through the entire process. So let's go ahead and start the process, and we'll start in research. Now research will have the field of study, observations, and we'll do investigations. Now in the research phase, it all starts out in the field, asking questions to the end user and knowing their feelings and thoughts on what they think could fix or improve on the product's problem. Being sure to closely observe the end user using the product and how they work with the product's problem, recording their behavior when they use the product and how it makes them feel, investigating the scope of other similar products and how they compare to your product's problem. With that said, what I'll go through now with the research portion And keeping in with the design thinking process, I will use a personal design job that I did some years ago as an example in this design thinking process. I'll explain everything up into what I did, which was a full prototype. So basically, I was given an opportunity to work with a small sports company to design what they wanted was their own lacrosse head. Now, to give you some insight to the lacrosse head, it's part of a sport called lacrosse. Lacrosse is a contact team sport played with a lacrosse stick and a lacrosse ball, as you can see here. It's considered to be one of the oldest organized sports in North America. It originated with the Native American people of North America, dating back as early as the 12th century, believe it or not. Now, lacrosse players use these netted sticks to carry, pass, and shoot a ball up and down a grass or turf field, as shown here, in an effort to score goals. Players use the head of the lacrosse stick to carry, pass, catch, and shoot the ball into a goal, as shown here. This is very similar to hockey, but without ice. It's played out on a field. So that's basically the information I needed to find out when designing this, because I've never played the sport before, so I had to do a lot of research, ask questions, and do some interviews. And I was given the opportunity to talk to college players and college coaches to understand what type of a head that was needed, that this company wanted to make, who they wanted to make it for, and how they wanted it to be made. So as you can see here, this is the actual head of a lacrosse stick, and you can see the netting is with it. This is all information I had to find out about. And I also found out that they were used in high schools, they were used in colleges, as I said before, and also they're used professionally, which is a universal version as well. And in this instance, though, we wanted to concentrate on the college version. So with that research in mind and that type of product, I had to go to then define. And basically in the define phase, you organize and develop a deeper understanding of the information you gathered. So basically this is the phase where you create a comprehensive presentation of the research that can be used as reference. After going through the research information, this phase will allow you the opportunity to ask questions against the research that you collected, and then give you an opportunity to redefine the problem and redirect your approach if it needed. And also, with a redirect, you can go back to explore new ideas, could help you find a solution to your problem faster, of course. So basically this was one that we would purchase, look at other competitors, and basically then reverse engineer that to kind of get an idea of where everyone else was coming and which way we would want to go. And here basically we cut one up. Actually, we cut several up. We looked at the thicknesses, we looked at the type of material that was used. We figured out what that material was, having it tested. We looked at the sizing and how these things were developed just from taking and studying the parts. Just like kind of how you did the whole thing of what the research end was, now we're doing it to the actual part itself with the competition. And then, of course, here we took apart all the netting. We looked at that as well and how it was strung up and placed onto the actual head itself. And, of course, we have the reference data now that we can then move forward into the next phase. Now, if we needed to, we could redefine it at this point, like I said. And with the redefine, it does allow you to have explore new ideas. And with those new ideas, we can create a new approach. And the data research can be interpreted as trending data as well. And we looked at the different types of offsets now within the head. These are now side profile views of the lacrosse head, basically, and we're given different ideas as to maybe we can make this an offset, we can make it a slight offset, or it could have no offset whatsoever. Here you can look at the different openings, the different channels, and the necks in them, as well as how some of them are strung up as well. We looked at colors, we looked at the strings, different styles, and they were very much custom. And then the different sets of holes what you needed to, maybe if you wanted to change your stringing style, you were given the options. And then of course the type of material you'd use and the different colors. The next area of the process, we go from define to ideation. And ideation is basically, there are no bad ideas here. And you want to be able to be open to many possibilities in order to get to the good ones. The main three areas in ideation is you want collaboration, brainstorming, and being able to visualize the ideas that come from the collaboration and brainstorming. And we'll go through this. Now, brainstorming, you have a basic technique. It's not just throwing up ideas and just saying things as you feel they come to you. You really want to have control and have it organized. One way is to have a facilitator. The facilitator will help you keep things on task. And you want to be able to invite a diverse group of people, that is from many different departments that you feel would be helpful. This could be anywhere from financing, engineering, tooling, people that will help to give you ideas from their experiences and from the departments that they are from. And you want to structure the brainstorming. And one way is prepare the group to start thinking creatively. And what you want to do is you want to use note cards to write down sketch ideas. And you want to be able to share and explain the ideas and place them on the board. And then you're going to organize these ideas on the board to three different areas. We have categories, rankings, and columns. So one way we used to do good, better, and best. Now everyone's idea was a good idea, and then we take those ideas, move them to the better, and then eventually agree to what was the best. And that was after you basically had all the ideas written down. And then you actually decide to keep or remove ideas. And then from that, you record all the data from the brainstorm. And then as an industrial designer, when you usually were the facilitator of this, you'd take the ideas and then flush them out. In meaning that you'd be flushing them out through sketches, through renderings, and getting people's ideas that they thought and then putting them to actual visuals. As you can see here, these were the ones I did with the lacrosse head. Now with the ideas that were flushed out, you're going to take those, and when you have the follow-up meeting, you're going to whittle those down to a certain few, and we're going to go ahead with engineering and then develop them into CAD and in a prototype. Now, prototypes can come in many different forms. They can be tangible foam model, they could be a 3D CAD model, they could be a 3D printed model. Now, the 3D CAD model is a great way to build a prototype because we can look at the aesthetics, we can look at volume, weight, dimensions, assemblies, and analysis testing, and we can get a very good look at what our product will become. You can then take it to the next level once as 3D printed models. And basically we go through SLA, which is stereolithography, and then there we can develop and look at surface issues, design functions, ergonomics, and also more importantly in this type is human factors. Now these are actual prototypes, and you can see some sketching on the actual prototype in order to maybe change some of the areas that seem to be problems. And in testing these prototypes, depending on what material you use, can then also, you could add more structure and engineering to the part, as we did here. And then the lower pictures you can see here were actually a final prototype. So when this model was then finished, it was then presented and shown and given the go-ahead to be produced. They basically went then to tooling and engineering, and then eventually to manufacturing. And this part was then completed. And that's basically how an industrial designer will then work within a project. So if we kind of take a look and go back to see where we kind of went from, where we started, and how we can actually see that if there's an issue with the product or with a functionality of the product, we can go back and redefine and then go ahead and move forward. Now, sometimes it may not just go back at all. There's been times where things were all the way through to almost build and production, And what happened was that it just wasn't going to work. So it went back and it couldn't be solved. So then, or there was no money to help it get solved. So then the project was then cut. Basically, this is where the industrial designer really kind of is placed. He has more than just one area, and he does help out in many different areas in the product life process. And again, we can look at the process of design thinking, where we start with the research, the define, the ideation, the CAD, the prototype, and then, if needed, we can go back and redefine everything and research the whole project to see if we can come up with another answer to a problem that we learned, maybe through ideation or within the prototype. Here are some course recommendations within I Get It. The Sketchbook Pro course is one when you want to develop sketching. You can use a program or a software that's called Sketchbook Pro. Basically, it teaches you how to sketch, how to use colors, and how to shade, and how to actually render out your ideas. There's the Siemens NX visualization course, which is basically a rendering course for Siemens NX. You can take your 3D models that you create within NX and use it to render it out, place it in an environment. That course shows how to present your model and rendering it for presentation purposes. There's also the Siemens Design Thinking Using Realized Shape. That one is a course that basically shows you how to create a part or a product using Realized Shape, which is another application within NX that allows you to use more of B-spline type functionality to shape surfaces, pushing and pulling surfaces and things like that. But it kind of takes you through the whole visualization of rendering and in actual like presentation format, as well as teaching you how to build within NX. 3D experience course, which is a plastic part design, which does the same thing, but it does it with a drill driver. It actually will take you from beginning to end and how to design and then allow you to customize the actual part itself. We also have fundamentals of PLM, product life management. We also have fundamentals of vehicle design and packaging, which basically take you through designing a automobile and showing you how it's packaged, and show you a lot of the different ways that you can look at designing a vehicle. So this is basically the end. If you have any questions, you can contact me at eric.banson@tatatechnologies.com. For information, you can also visit our website, which is myigetit.com. And thank you for attending.